Welcome, everybody. Welcome back. This is our sixth and final session for this week's boot camp. We've got Trey McAllister back. Trey is going to, Trey works for TAMS, and he's been doing a lot with validation and coming up with tools to allow us to validate the MTConnect output from your different devices. So I'm going to turn it over to Trey, but we're going to give it about another 5 minutes. Let everybody else get logged in. I'm sure some people are just coming back from taking their break. So we'll get started at about 12:35 or 1:35, depending on which time zone you're on.
A little bit of small talk before then. Mike, I was trying to remember, I think it was around 2016, maybe 2018.
Mm-hmm.
I was attending at that time it was a tag meeting. And I don't remember if it was you or somebody else from one of the other integrators was mentioning that they had built a validator out of Excel. Was that you?
No, that wasn't us, but I don't remember that one. So that might have been before I started. That'd be interesting.
Mm-hmm. Maybe if Neil's in the room, maybe he can chime in if he knows or will.
Yep. We're getting everybody logged back in. We're up to 35, 40 people, so we'll give it a few more minutes. Alyssa, are you still online?
Yes.
We go ahead and add Neil and Will when they come back in now as presenters. I've got Neil on text message, and I think that might be valuable. You know, they can mute themselves just like I do, and then that way, if we need to have some input on this session, I think that's a great idea.
Okay.
All right, it's 12:35 here in Chicago, but 1:35 on the East Coast. So we're going to get started. Trey McAllister is with us again this afternoon to talk about validation and what he's been able to do in that effect. And we're also going to add in both Neil and Will as being able to, put their comments in on this session as well. So this will be kind of our wrap-up session as well. So we're looking to get Trey's discussions of what he's been doing and also then be able to answer your questions during this session. So Trey, it's all yours.
Thanks, Mike. Let's see. I guess before we get in here, looks like Ben has a quick question regarding adapter output. I've used Telnet to access the data stream from the machine to see what it's sending. Is the data shown there the only things the machine can report, or is it simply the only things the adapter has asked for? It is generally what the adapter can support. So I guess from the context of if the adapter has asked the machine for that information, it would be that one. So there may be times, and we've encountered this before we did our own adapter development, is that it can be really difficult when you're dealing with just an adapter vendor, and maybe one that doesn't have great documentation on what types of data items can come through that adapter. You may have to kind of monitor that adapter for quite a while before you see all of the data items come through that shutter. So we always recommend, if you're dealing specifically with an adapter provider, an integrator that focuses purely on just providing adapters, that they supply an accompanying devices XML to go with that adapter. So, all right, so getting here into session 6 for validation, a little bit of background into how I got into this position. As I said in session 2, I with True Analytics Manufacturing Solutions, TAMS for short, and we started our company providing machine monitoring purely based off of MTConnect due to the value of having a standardized information model that we could just hit the ground running with developing analytics and dashboards and things like that. After probably only about a year and a half and working with various customers and other third-party integrators, we quickly realized that not all implementations of MCConnect are equal. There are some implementations that are, they're great, comprehensive implementations. It covers a wide array of data items, and they follow the expected syntax. But then there are others that slap MTConnect on the side of the box and call it good. But for a client application like ours, it was not able to process the data, because it wasn't following the standard. So from there, we grew into a role based off of processes we developed internally. We found ourselves in a role where we started developing more validation tools for MTConnect, purely out of necessity of trying to get ahead of the curve. Right. Session 6, validation of MCNEC output. Just like with all the other slides, here's a couple helpful links to get started. We're going to be referring a lot to the model browser, or the model portal, as Will's calling it. So this is the interactive web application that you can use to navigate the actual MTConnect standard. There's also a link here to the raw version of the MCNEC standard that you should be able to access an XML file through this GitHub repo if you really want to get into manipulating the standard. That's a way that you can do that. And then finally, the TAMS validator. We're going to be demoing this later on, kind of supplementary to showing you what it takes to validate an implementation. And just to pause there, there was a question in the previous session about, what is an MCNECT implementation? When I say implementation, I usually mean primarily an agent, the existence of an agent, being that an adapter is technically optional and not part of the MCConnect standard itself. Uh, you know, I'm optionally including that as kind of the umbrella of implementation. Continuing on here with some terminology. I'm going to kind of lay out the expectations of who the actors are in an implementation and kind of what their domain knowledge requirements are. So how well do they need to understand the MTConnect standard uh, in order to uh, effectively use the output? So first here we have implementers. This would be OEM builders, machine tool builders, or third-party integrators that are offering adapters, or just MTConnect solutions in general. These are the actors that are publishing data through an agent in some way. What's required of them is actually substantial. They need to understand how to get data from a piece of equipment or a sensor. That could be a wide array of different APIs, SDKs, and different machine level protocols to be able to kind of sniff out information or request information from a machine. Beyond that, with respect to MCConnect, it also requires them to understand quite a bit about what vocabulary is written into the standard and how to kind of transform or translate the proprietary data from the machine or equipment into this vocabulary, as well as how to structure that vocabulary in a contextual way, that this load data item fits within the component structure of the linear axes, and this is the x-axis load. They need to understand what that structure looks like and how to model it. And then finally, they also need to have a substantial understanding of the MCConnect protocol, what's required to provide an agent, because that is technically required according to the MCNEC standard, to be able to publish the data. Obviously, there's companion specifications that you can work with, so it doesn't have to be the rest. The next actor here would be applications. So, starting off with TAMS as an example, we started off purely as a machine monitoring software vendor, but applications would be like, these are client apps that are subscribing to the MTConnect implementation, grabbing and requesting data from an agent. And they still need to understand some of the vocabulary and the semantics so that they can properly utilize those terms and that structure to do things like analytics or develop AI or sort of homogenize dashboards across a wide variety of equipment. But they also need to have a substantial understanding of the protocol so that they efficiently request that data from an agent. And then finally, we have the end user. This would be, shop floor managers, machinists, anybody that's potentially looking at a client application like machine monitoring. Ultimately, ideally, because of the terms that we've defined in the MCNEC standard, they're all pretty commonly understood terms. Ideally, it requires a minimal understanding of the actual definitions in the MTConnect standard for those terms and structures. Ultimately, we're going to get in here to the 5 W's, if you will, of validation. So first off, who's responsible for adhering to the standard? This is a really simple diagram or like flow chart. If you're the end user, you're leading the digital transformation for your shop. First question you need to ask is, who provided this MTConnect solution? Was it the machine tool builder or Was it a third-party integrator? If it was the builder, go to the builder. You shouldn't have to worry about if the builder worked with this, integrator, like integration partner or not. Just go to the builder, ask them if they validated their implementation, and if so, did they use a third party to help certify or validate that implementation? Same questions can be asked if you're going direct to a third party integrator. So what is validation? So these are three sort of levels of adherence that we've defined within the validation working group. First, we have structural, and this degree of adherence really just measures how well have the terms that you've used in your device's XML, and the structure that you've put those data items into the component model adheres to the constraints and rules defined within the MCNEC standard. So if you're using the right terms together, and if you have all of the proper required attributes in your XML file, then you will be structurally compliant with the standard. The next level of adherence, and by the way, this kind of goes, this kind of stacks on top of each other. So you can't really validate the behavioral aspects of an implementation until you've validated the structure. And same thing with capabilities. You can't validate that until you validated structural and then subsequently behavioral. But going into behavioral, this really just measures how well you've followed the protocol side of things of the MTConnect standard. Are you implementing the REST API as it's outlined in the model? Do you have all of the required and recommended parameters? And do you support things like interval? Those are all behavioral aspects. And then it kind of bleeds into a mix of structural and behavioral, but is the agent recovering from data being pushed to it by an adapter that may not be compliant with the standard? That also kind of falls within the behavioral side. And then finally, this is everyone's favorite topic within the MCNEC Standards Committee, is capabilities. This is when we start to really get into fun topics of how to use MTConnect. Capability adherence would be, I have an application that I can track OEE over time. So I need MTConnect to provide me with the necessary data to calculate OEE. So that would be the use case, and capabilities adherence would be validating whether or not a particular implementation has all the required or recommended data items to facilitate that calculation. Other examples would be, if you have a digital twin or you're developing a specialized AI, those are all going to have specific requirements of what kind of data is coming from an implementation for that application to work effectively. When should I validate? So this topic is kind of emerging. We've noticed at TAMS really over the past year we've fielded a lot of questions from some of our customers and contacts. You're telling me that following the standard is important, but when should I check that? I don't really want to wait until the machine that I just bought, is here, and then go back to the builder and say, you need to fix your MCNECT implementation. So one thing that we recommended is, you can simply put these requirements in your purchase order requirements for new equipment, retrofits, or even when you're talking to third-party integrators directly. And what I would recommend with this, and we can kind of touch on this later, is developing an internal process as well, that identifies how you're going to certify or verify the certification or validation of that implementation. So we can touch on that later with respect to the different options that you have available for that. Other examples of when would be, you already have an implementation on site, and now you're about to collect data. Well, before you put anything in the database, or data lake or Excel spreadsheets, floppy disks, whatever your medium is for persistent storage, make sure that it's valid before it goes in there long term. Because one of the things we like to highlight is that data is the new gold, right? If people had all of their data over the past 15 years connecting to MTConnect, with the advent of AI now, there'd be a whole lot more valuable AI already written by now. But there's kind of a bit of a catch-up period right now where we're having to now think about collecting that data and storing more of it, so that we can have better contextualization for AI. So think long term. If you're planning on storing into this data long term or feeding it into an AI, make sure it's valid beforehand. The last example is, if you have any sort of real-time, quote unquote, dashboard that's maybe just relaying information from an MCConnect agent, you should probably validate that before it goes up on the display. Otherwise, you might have to answer questions from machinists trying to understand, from their Haas machine, what does execution 0 mean? I don't understand what that is. But if you validate it beforehand and you can kind of filter that out and say, hey, we have some anomalous data here. Don't pay attention to this value. You can really kind of avoid confusion on the shop floor. Right. So kind of a similar topic here with the 5 Ws, but where does validation fit? Based on the conversations we've had with customers and contacts, anytime that you have regulated process data, you have ITAR or CMMC, and you're kind of required to store data long term, it fits to the last slide. You should validate that data before you store it, and that applies to these regulated spaces. If you are part of a data science team, maybe you are part of a larger enterprise, and you're more involved on the manufacturing side, production team, and you're leading the effort in digital transformation, but then you pass off the analytics and data processing to a separate, computer science department. Well, they may not, the folks in data science may not understand all the nuances of the manufacturing terms like you do. So if there are any terms or values that are not called out in the standard, it can be difficult for data scientists to understand the context of what that data actually means. So if you validate it beforehand, you can help ensure that long term you can tell the data scientists, just refer to the MCNEC standard and it will tell you everything you need to know about what this data means. And then another final example here is with supply chain data propagation. So this is a topic we've heard quite a bit within the Institute, as well as I've personally had outside of the Institute. But this idea of, enterprise level manufacturers invoking requirements upon their supply chain that in order to comply with regulations that they have for process data. So you might start to see some of these aerospace and defense companies requiring of the small job shops, you need to give us the full snapshot of temperature for the heat treat operation of this part. We need to know all the fluctuations and the cool down rate and everything, how quickly that actually happened across all the sensors, and you need to send us a package with all that process data. But each layer up the supply chain to the enterprise is going to want to make sure that that data follows the standard before they consume it. Otherwise, there's no context for what which sensor this temperature value came from, or um, any of that kind of information. Why should I validate MCConnect? Uh, it's a lot of kind of regurgitation here, but examples of why would be, if you have a plug and play client application, for example, Tams is wrapping up development of a new plug and play like HDMI stick device that theoretically connects directly to an MCConnect agent. So there's no like tag mapping or anything that you might have, uh, with some other monitoring solutions. But the only way that that works is if the MCConnect implementation utilizes the semantics and vocabulary, that device and the software on board is able to utilize the information model defined by MTConnect already to make a lot of assumptions about, how should I display this type of data, in a meaningful way that's kind of homogeneous with other monitoring applications. Another big one, point of discussion lately is artificial intelligence. I keep stressing this, but garbage in, garbage out. You cannot effectively train an AI with non-contextual data. At some point, a data scientist takes a bunch of raw data, and they're either going to have to contextualize that by hand, or they could utilize something like MTConnect to automate that. But they can only rely on the MCNEC data if it is properly and validly contextualized. Environments where this is also critical, and we've experienced this too, is if you have a shop with a mix of different types, makes, models, and vintages of CNC machines or sensors or whatever. MCConnect is great about homogenizing the data across that entire landscape. Where it's a bit more difficult with other standards like OPC UA, where you might have to do a sort of a custom mapping, or a separate node set that you have to define for each type of equipment. Another example that we've seen firsthand is if you have multiple facilities and you're trying to remotely monitor equipment, across, buildings, on a large campus, or even if there are several campuses, in one state, or even a state away, but you have somebody kind of at a higher level overseeing all of production, having the homogenized information model, the information model that applies to all types, makes, and models and vintages, is incredibly helpful, and makes it a lot easier on those folks. All right, so we're about to get into examples, real world examples of the actual XML violations. But before I get into that, I'm going to kind of give this caveat here that when we talk about validating the XML, or validating MTConnect specifically, I like to warn people that validation should consider the context of the intended version that's implemented. So there's been a lot of talk throughout these sessions about there's this OEM or this builder or this integrator that is still running version 1.2 or 1.3 of the MCNEC standard. Well, there may be a reason for that. It may be that the piece of equipment can only support the vocabulary and semantics of 1.3 of the standard. So the implementation itself is kind of capped at 1.3. So if that's the case, then I think we should be validating that document in the context of what was allowed in version 1.3. This example here with execution, program optional stop was deprecated in version 1.4, but in implementation intended for 1.3, it would be allowed. So I personally would view this as valid. And if you If you disagree, feel free to join the validation working group. It happens every other Monday, and we can argue over that. All right. So getting into the examples, we'll start off with structural adherence to the standard. So the process that TAMS developed, at least internally, and that we recommend, is that the first step of validating just the structure is to look at like the the raw XML output, and you can get the output by doing a probe request, doing a current request, and that'll get you the two main types of response documents that we need to double check. Alternatively, just go directly to the device's XML if you're using the reference agent or an agent based off the reference agent. And the next step we're going to do is we're going to look at the header tag towards the top of the XML and refer to the version, because this is intended to be a reference to what the intended version of the implementation is. Alternatively, you might want to also double check the XML namespaces defined in the root node of the XML document. The namespaces should have a reference to the schema definitions, and those schema definitions are typically suffixed with the MCNECT version. Once we understand what version we're working with, I recommend just start from a high level, review the tag names, look at the vocabulary used in the tag names, where those elements are in the element tree, and then start reviewing the attributes after that. As you go along and you're looking at all the terms in that document, have a point of reference to the standard. You can always go to model.mtconnect.org to get the latest, and that tool is fantastic now because it gives you the context for when things were introduced or deprecated or even updated now. All right. So as we talk about structural adherence, I just want to highlight that there's kind of a hierarchy to where you start off with in terms of evaluating structural adherence. The actual XML structure and the semantics and the vocabulary. The first layer here is XML. So obviously, we'd be referring back to the W3 specification for what XML is. But if you violate those basic rules, then we can't continue. I'm sorry, I can't validate your implementation because you didn't even follow the underlying XML specification. The next layer beyond that would be XSD, or schema validation. So if your document fails schema validation, that's another quick and dirty way of checking adherence to the MCNECT standard is to utilize the schema. I think Neil went through that in session 3 and possibly session 4 with the capabilities of Visual Studio Code. So you can refer back to that session for live examples. But that's kind of the next layer. And then finally, we have MTConnect standard. So, there's a lot of rules and constraints defined in the standard that go beyond the capabilities of just simple XSD validation or XML specification. So you can refer back to the MCNEC standard for some of those nuanced constraints and rules. So that's what we're going to be checking here. All right, example 1. And by the way, all of these examples we've seen, in the industry when we've gone to try to connect existing implementations to our monitoring platform. So I've tried to anonymize all of these examples, but they are real world examples that you can keep an eye out for. All right, so example number 1 here is, a really simple XML violation. It's a violation of the XML specification that on the left here, we see the highlighted area. We're missing the end tag for devices. So the fix there would be to simply add that end tag. I've seen this quite a bit, especially when people are copying and pasting XML directly from the browser when they do a probe request, or even when they're copying it from the device's XML. Because often what happens is you may need to communicate back and forth with, what is the device model? Oh, I'll make an addition here or there, but you can't send the file via an email. So people will copy and paste the XML and paste it into an email raw, but they'll miss part of the structure. So obviously in this case, the applications won't be able to read this XML. All right, for this example, we have an example of schema violations. So in this case, this is and I think Neil had examples of this in session 3 and 4. But if you have IDs with the same name, those are constraints defined in the schema. So if you violate this, you're violating the schema specification. So here on the left, we have 2 exec IDs. The solution would be just do anything you can to make that unique, even if it's just adding an auto incrementing suffix. This can really impact, if you allow this to persist, it can impact, maybe composite keys in a database or even, lookup fields for database. You're going to have sort of conflicts and duplicate sets of data or misrepresented data. And I'll also note here down on the bottom, I tried to add links directly to the model browser where you can look up some of these specifications. So actually, if I do that, I don't know that it'll let me with the laser pointer. All right. So if I click on that link, in this case, it'll take me directly to the definition for a data item, which is what we were looking at. And I can review the ID property. And you can review that, this has to be a unique identifier for this item. Get my laser pointer back on. All right, here's another schema violation. So in this case, we have a sample sample observation that you would see in the streams document. And in this case, there's a load data item that is errantly reporting out test. So what's wrong about this is that samples expect floating point values. So passing a string like this is a violation, not only of the XSD, but also the MCNEC standard. There is kind of a slight exception to that rule, which makes it difficult with XSD. But you can also have unavailable. So the fix here would be, report out the right value, make it a floating point. All right, so now we're getting into MTConnect violations. So in this case, what I'm specifically trying to highlight, although there's a couple issues here, what I'm specifically trying to highlight is the name attribute on these linear components. They have to be unique within the context of its parent, which in this case would be axes. You cannot have duplicate names on the same level. So the fix here would be to add a suffix to the names of those linear axes. Right. So this one is interesting, and it does require reaching out to the vendor of the MTConnect implementation. So reach out to the builder, reach out to the third-party integrator, whoever it was that supplied the adapter and or the agent, or if it's more of an in-house thing, or champions in-house have been editing the device model, reach out to them and ask them what the intent is here. But what we're looking at here is we've defined that this data item is a sample type of data item, but the specific observation type is path feed rate override. But if I review the standard, and I specifically, let me get rid of this laser pointer. If we pull up, in this case, the definition of path feed rate override, and I'm looking at the model browser, I see that path feed rate override is actually an event type, not a sample. But there's a similarly named path feed rate data item. If I search for that, path feed rate, you'll see that it's a sample type. So in this particular example, I don't know if they meant that the category is supposed to be event and this is path feed rate override, or it's actually supposed to be path feed rate and it is a sample. So that's what we're highlighting here. You'll have to confirm that with whoever developed that device model. Okay. So this one is also kind of along the same lines as the previous example, but in this case, we have a situation where you have the wrong subtype in association with the observation type. So position does not have a subtype of current available in the standard. If I look that up in the model, I'll do a search for position. I'll have to go down here a ways. So sample types position. If I look at this in the model browser, I see the subclasses here. The options are actual, commanded, programmed, and target. I don't see current. Okay, so that's technically a violation of the standard because you didn't extend that. But then I also have another data item here where I have an extension, but it's actual. So I don't know exactly what's going on here, but if I do change current to what I can kind of assume might be actual, but then I fix the unnecessary extension, then I have duplicate data items. So there's just a lot of confusion here. And I think what I would do is I would have to choose which one of these data items to delete and just change both of them to subtype actual. And Will's highlighting back on this example, overrides are considered events since the change discretely, since I'm assuming they change discretely like a controller mode. There's no interpolation between an override 100 and 50. Right. So here on this example, this one has been somewhat contested, and I think it's up for discussion in the next standards committee meeting. We're going to kind of open up the discussion more broadly to nail down how we need to update the terminology in the standard. But the way that the standard is written now is that a sample type must have units. This is the observation, but let's see. Sample. It's way down here. Data item types sample. Okay, so units, the multiplicity is set to 1, meaning it's required. And there's discussion about what the role is of default values. Each one of these properties has a default value that you can refer to. So in this case, if I also look up the load data item, it is validly a sample. But if I look at the units override for that property, the multiplicity is still 1. It's still required, but the default value is set to %. So I think what we're going to discuss in the next committee meeting is maybe extending documentation on the units property on the data item to provide more specificity that this attribute could be omitted and assumed, the default value assumed for this node. So, but the way it's written now, and the example, the reason I bring this up is if you use like the TAMS validator, it's following that multiplicity rule first and foremost, and we don't have the logic in there to consider the default value. So something like this will actually throw up an error exception in the validation report. All right, so this one's my favorite. It's been a topic of discussion for as long as I've been involved with the Institute. But in this example, what's happened is the adapter has just pushed execution states in terms of integers. They did not translate those integers into the vocabulary in the standard. So when it reports out 6, I have no idea what 6 means in terms of execution. And if I look up execution, we see that the result type is not an integer, but it's actually of type execution enum. So if I click on that in the model browser, it gives me the list of what are the acceptable values or result values that can go between these two tags. And 6 is not here. So the fix here would be to either go back to the vendor for the MCNECT implementation and say, hey, can you fix this issue and translate these integer values into the MCNECT vocabulary for execution enum. Alternatively, the reference agent and some other agents support things like Ruby scripting or other scripting options to where you can kind of fix this in your own environment. So you can actually create the logic yourself to translate those values if you know what they mean. All right. So I told you guys I would touch on this, but Neil actually touched on this quite a bit yesterday as well. But the issue here is that specifically the name attribute on the axis component, which a linear and rotary axes components are an abstract of axis. But if I pull this up in the model browser, yeah. All right, so it's in the description here. But the description here in the axis component describes how you should, what the format is for the naming conventions of the name attribute. So you can't put something like foobar here because it wouldn't be easily understood by a client application what type of axis this is. Is this a linear x-axis? To where maybe I need to try my best to render in a web browser a line for the x-axis versus a perpendicular line for y-axis and a vertical line for z. There's not much context into foobar. And just to specify here, the standard specifically refers to ISO 841 for recommendations on those axis names. All right, now we get into behavioral validation, which is quite a bit shorter, and then capabilities validation, and then I think, Mike, it'll be good time for a break. So how do we go about validating behavior? Well, first step is to evaluate which REST endpoints are actually implemented in the agent. Does it have a probe, current, sample, assets, all these endpoints? Do they come back with the appropriate MCNEC response documents? We've seen vendors try to develop their own agent from scratch, and they were lacking, these basic endpoints. So then you have to go back and forth with, the recommendation or the requirements from the standard. The state you need those endpoints. The next step would be to evaluate query parameters. The parameters that are defined in the protocol here in the model browser. We go under fundamentals, MCNEC protocol, and REST protocol. Here we have all of the requirements laid out for each of those endpoints, as well as information about some of those parameters and how they are expected to behave. If I expand this out, I don't remember, does this? There we go. So under the agent, if I look at probe, or better yet, sample, and I want to review the documentation on interval, which would allow me to stream the data more efficiently. This is where you can see, what the intent is behind that, behind how that parameter affects the behavior of the agent. So you can compare that documentation to what you observe in your implementation. Just like the structural, there's several standards that are referenced, and when you're evaluating the validation of an implementation, you can kind of step through these. If you are not able to make a standardized HTTP GET request on those endpoints, that's a clear violation of the HTTP standard, not even MTConnect. Same thing with the level of URI. If you're not able to construct a normal address or request in the address bar and get the expected response, it's violation of the URI. And then finally, the MCNECT violations would be kind of like I described. If I send an interval request or a sample request with an interval parameter, I expect the agent to open up a stream and continually update that connection with new data. All right, so examples of behavioral noncompliance. So this one caused a lot of headache for us at TAMS. We encountered a vendor that, like I said, they were attempting to make their own agent. Kudos to them for trying. But the first version that they sent us of this implementation, they did not sequence the sequence number. So every time we made a request and there was updated data in the current, we would actively see changes to path feed rate override. We would see it go from 0 to 100, but the sequence number stayed the same. The expectation is that sequence number is unique to that observation in that point of time. So under the same instance of the agent running, you should not see the same sequence number. The expectation, as I said, is that it auto increments the sequence numbers. In particular, the impact for us was that thankfully we hadn't connected this implementation to our monitoring platform, but if we had, we would end up with a whole mess of foreign key constraint violations and overwriting of data in the database. In the same scenario, this behavioral issue was that they sent another version of the agent that the instance ID did not change when you restarted the agent, which, we looked at that, we observed that, and we said, okay, this may be okay. They may be trying to implement persistent data storage of the buffer. So the idea would be that you start up the agent, you collect some data, but then the agent stops. But when you pick back up again, the agent reloads some of the data that was in its buffer before it stopped. so that it can serve that up again. And we confirmed with the vendor that that was what they were trying to do. So that's good. We said, okay, instance ID not changing is appropriate. Um, but they had, uh, what was it? I think, yeah, there was still some issue with how they reported those values. Oh yeah, they gave different timestamps, uh, and the same instance ID and sequence number. So it was technically a different observation altogether in how we processed it because it was a different timestamp as well. Um, so yeah, that issue resulted in like 100 hours of engineering effort to identify that one, it wasn't our monitoring platform that um, was at fault, but our dashboards were just all over the place in terms of metrics because we were essentially calculating the same 3 days worth of data over the course of like 2 weeks. Unfortunately, the resolution in that situation is that we ended up losing about 3 months worth of data due to a behavior issue with the agent. All right, so now we're getting into capabilities, and this is just kind of high level because it's still in development within the validation working group in terms of how we would recommend you go about validating capabilities. But step one would be defining or identifying your requirements. What sort of use cases do you have for MTConnect, and then distilling down from there out of these use cases, what types of data items or information do we need from MTConnect in order to deliver on that use case? Um, so right now, the validation working group is exploring, continuing the pattern of reusing existing standards. So we're evaluating the use of W3C's OWL and Shackle for semantic web. But the idea here, let's see if we, yeah, I can go into more detail here in a little bit about OWL and Shackle. But the point is we're trying to reuse those standards. All right, so levels of capability here. At this point, there's no real, underlying, you know, framework of existing standards that you have to adhere to. It's just purely the vocabulary and the semantics of MTConnect that determines whether or not you comply capability-wise. Beyond that, it's whatever the definition is of that use case. If you have an AI, it's going to have specific data items that, it's going to be, basing its calculations on. Or if your ERP or MES has OEE calculations built in, it's going to need certain quality data items or process time data items. So this example specifically is drawn from our machine monitoring platform. Most of our core features in terms of analytics, for providing utilization, productivity, and efficiency, boils down to needing, these four main data items. We need execution state, we need program active, and then some overrides. And that gets us the pillars of our monitoring capabilities. The impact if you don't have this is you don't get as much out of the reporting, or there's other more advanced engineering features that you won't be able to utilize for that particular piece of equipment. So this example specifically is something that we've heard from some of our other customers and contacts. They're specifically trying to monitor things like furnaces, where they need references to the programs and the temperatures and what material was put in to the machine, and they need to store that for quality assurance and quality reports. So if you don't have these things, as a implementer of MTConnect, then the customer won't be able to potentially adhere to the regulations or requirements from their supply chain. All right, and just to kind of recap, if you encounter any of these types of issues, how do you resolve this? And always, we've tried to stress this throughout the sessions. Always talk to your OEM or machine tool builder, if they're the ones that supplied MTConnect, and say, hey, this is reporting out wrong, or I need more data. I need the block, the code block from this machine, or I need temperatures or whatever, and see if they can work with you. If they're unable or unwilling to work on those solutions, then there's a whole market of third-party integrators that are happy to help either develop new adapters or help provide guidance to machine tool builders on how they can deliver on these requests. And with that, this is a good slide to end on. I can let you guys think about this over the next 5 or 10 minutes.
Okay, great. Thank you very much, Trey. Let's take our 5 or 10 minute break. So it's about 30 past the hour. So at about another 10 minutes at 1:40 or 2:40, we'll reconvene and finish this one up. Welcome back, everybody. We'll let Trey continue with his presentation. And then at the end, we'll have all 4 of us, Trey, Will, Neil, and myself, available for questions and answers at the end.
All right, thanks, Mike. All right, so hopefully you spent the last 10 minutes thinking about, gosh, that was a lot of work to just read XML. And I know for myself, there's times here that you'll have hundreds of lines worth of data items to look at. I've seen as much as like 1,000-line XML document, and it is a bore and a drag to read all this by hand. I did that very early on with TAMS when we started developing our validation processes, and it is not fun. So I feel bad for all the folks. Yeah, Neil says job security. No problem there. So if you were kind of stressing about the mountain of work ahead of you with validation, just know that there's light at the end of the tunnel, and the computer can just do it. So this has been a major effort for the validation working group specifically, is trying to address ways to alleviate the burden of checking the implementations. What are several different options or avenues that vendors can go through and customers can go through to validate their implementations and make sure that their data follows this very valuable semantic and vocabulary structure, this information model. So we'll touch on this in session 5, and I think I touched on it briefly with session 2, but as of version 2.5 of the MCNEC standard, we added some additional properties to things like the header and data items and observations to enable what we call agent active self-validation. So this concept is, as we'll touch on it, if the agent supports this, you can update the agent config to support validation. And it's the role of the agent to ensure that this validation attribute is added to the header of response documents. So if validation equals true, if your client application reading the responses from MCConnect, just look for this validation attribute. If it isn't there, it's assumed to be false, that this agent doesn't support validation. And we did this to accommodate, obviously, other agent vendors. If an OEM supplies their own agent and they don't want to go through the trouble of implementing validation, they don't have to. And client applications can now just assume that if validation is not in the header or it equals false, then I can't rely on this agent to kind of self-regulate here. In terms of data items and observations, again, we have this classic execution status 6 example that if you encounter this and the agent has active self-validation and it's able to determine and identify that 6 is not a valid result for the execution data item type, then its role is to add this quality attribute and specify it as invalid. Again, this quality attribute is similar to validation, that if it does not exist, it's assumed to be in an indeterminate state. So let me try to pull that up. You'll have to bear with me because I always forget where it's kind of buried in here. I think if we go to data item, and then you have to, maybe it's observation. All right, so yep, there it is. So there's a trick here in the model browser, in the old version of the model browser, where you have to use the arrow keys to kind of tab through these rows. But the quality attribute is kind of hidden here in the observation. But you'll see here that the result type for quality is a quality enum, and there's 3 states for it. Invalid, obviously violates the standard in some way, but the default state is unverifiable. So this leads with the assumption that this agent is not capable of doing active self-validation. Otherwise, we ideally would just see valid on all these observations. Right. And then this final note here, if you are part of an OEM or a builder that does develop its own agent, or even forked off of the reference agent, and you're kind of maintaining your own branch, this may seem like a daunting task to have to develop a whole software architecture around validating all of the hundreds of data items and components and all the rules and stuff with the MCNEC standard. And for that, we came up with a solution as well. So the next slide here goes into a project spun out of the validation working group as a result of Tams's work developing the online validator that we have. But this project is called the MTConnect Transpiler. And like I said, this was kind of started with ideas that I had working with TAMS, but we were able to collaborate with the MCNECT Institute and AMT to help deliver a set of open source libraries under the MTConnect organization on GitHub. But really the catalyst for this, the background for this project is that when we encountered that implementation that just had a lot of issues with the agent and poor vocabulary usage and bad semantic structures, it was really just a difficult implementation to work with. We set out to automate or come up with a software solution that we could just, in a command prompt, specify an XML file and have it spit out an Excel report. That was, version 0.1 of TAM's validation. And I was able to do it but it took about 6 weeks of constant development to come up with a prototype of this. And that prototype was capable of just doing some basic validation of the category and whether or not the type was compatible with that category, if the data item subtype existed, whether or not it was compatible with the specified type and category, and then some other kind of nuanced things like units. But it only checked, less than a handful of different attributes in the entire document. So it was a really, really basic validator, but it took a lot of time and effort. And then I found, because it took about 6 weeks to develop the validator to support up to version 1.6, and I set out to ensure that I could validate everything from version 1.0 up to 1.6 in those 6 weeks. But then we had other implementations that went up to I think 1.8. So as I was trying to update that architecture to support up to 1.8, I was finding that it was taking between 2 and 3 weeks with each version of the standard that was released to pour through the documentation and handwrite all the code to enable this basic validation. And it was just, I knew it was going to be unsustainable. So thankfully, ironically, around the same time as I was developing this, Will and team were hard at work migrating to SysML for MTConnect. And understanding the capabilities of having like a machine readable model for the standard, I immediately figured that we could utilize that XML document that represents the entire MTConnect standard, and we could use C# to deserialize the entire standard model into memory in a computer program. And then we could use existing workflows and libraries to what I call transpile. It's a combination of transposing a model and then compiling it into a different format. So thus began the work of developing the MCNECT Transpiler. This particular project, MCNECT Transpiler, is simply capable of deserializing the XML document from the MCNECT standard into memory, and then its job is to pass that in-memory model to another library in a pipeline. An example of that is there's an example project in this GitHub repo, MCNECT Transpiler syncs.c#, that will take that in-memory model and then use a common template engine library called Scriven to write a bunch of C# files. And those C# files create a mirror of the MTConnect standard as you see it in the model browser, but in an object-oriented format. So you can, in Visual Studio, you can navigate the MCNECT standard through objects and properties, much like you do through this structure. So you can get all the way down to device and access all the value properties and understand what its expected type is, when it was introduced, what the multiplicity is, default value, documentation, anything defined in the standard is now represented in this project as a C# model. So we're looking to expand out other languages that this transpiler architecture could support. We have a lot of interest in like Python. And we're happy to discuss these things in the validation working group and see how people can get involved and making this more supportive. But going back to the agent active self-validation, you can utilize the MCNECT Transpiler, something like this C# sync, to automatically generate all of the like the full list of all of the data item types and the relationships between types and subtypes, and for certain events like execution, there's this subset of values that's allowed. It's a lot easier to write all that logic through something, like a template engine. All right, so I said I'd come back to this topic, and you'll have to forgive me. I'm not as well versed in these as Will is, because Will is the one actively looking into this. But the validation working group is, like I said before, evaluating existing standards that we can utilize to provide recommendations on how to describe a use case. But we wanted a way to, in the same tone, describe a use case in a common format, but also be able to make that actionable. So once you define or describe a use case in this standardized format, we wanted the ability for people to then, run an XML file up against that definition and validate it, and validate that use case. Specifically, the use of Shackle, and I think the next one is Sparkle. It really enables whoever's defining this definition to get really granular with the constraints and the rules that your use case requires. So if you have a really advanced use case, like maybe AI, or like a business logic, type of use case, you can build that into this definition and be able to, run an XML file up against it. So I'm sure once we develop this further, I think it would be great to have another session like this, just purely based on how to work with these other standards and format it in a way that you can validate against. All right, so I've explained a bit about how the agent, the reference agent at least, supports active self-validation, and it's written into the standard as a recommendation to offer some level of validation, in your implementation. But here's some examples of commercial options that exist that support validation. So Will's company, Metalogy, they have their meta agent that I believe has some form of self-validation. And last I heard, he's got some updates coming. It's a lot of work to set up a transpiler and set up the architecture to actually perform validation. But I know he's hard at work at expanding the capabilities of that. Then TAMS, we also supply an online validator. Just go to validator.tams.ai, and anybody can upload an XML document and get like a free spot check. You'll get like a green check mark or a red X to just indicate whether or not that follows the standard. Our validator admittedly does not cover everything in the standard, but we do cover just about every property on data items, observations, and components, and whether or not it follows the right vocabulary. We're actively working on getting 100% coverage on the attributes of every element and every property within the XML document. I think we have about 90% coverage on those. And then we have about 50% coverage on the semantics structure. So we're actively working on being able to validate things like component models and compositions and interfaces specifically. If you subscribe to the validator, you'll get like a comprehensive report, and I'll kind of walk people through that as an example of how you can go about validating an actual file. And then TAMS also offers an agent auditor. So this is a service that can be installed alongside an agent, that does the same level of validation as the online validator. It will just send an email notification uh, with a list of any violations to the standard as the agent is running. So that's really helpful, specifically like if your agent doesn't support self-validation, but you want to catch things that they may not kind of rear their head until maybe months down the line after an install. Maybe the adapter just forgot to translate one execution value into the terminology, and it just spits it out as 0. I think we actually encountered an implementation like that. They had all the other execution states mapped, but there was one enum that 0 would pop up, months or even a year after the install. All right. So going back to what's been added to the standard and the active validation within the agent. If the agent does support active validation, then you can go to the errors endpoint introduced to version 2.6 of the standard. And this document, as Will kind of highlighted earlier, there's an abstract definition of the document, but the guts of it ultimately follow this structure. So you'll likely see a collection of these exception nodes, which specify the severity level of this particular violation. And then there's additional context into what type of standardized code this violation was. And these exceptions apply not only to things like data item types and subtypes and whether or not you got the right category type combo, but it also applies to more constrained logic, or more specific logic, like the access name has to follow ISO 841. Those types of exceptions could be reported here, and they should be described pretty well with this structure. Right now, maybe Will in the chat, you can specify, but I don't know if the reference agent supports the exception report yet, but the TAMS online validator was used to kind of proof this structure and make sure that it was achievable. But the online validator is capable of spitting out this report. All right, so so Will said, not yet. We have not got there yet. It's in the works. So like I said, it takes a lot of development to get a transpiler up and running and to really effectively implement validation. But I know he's hard at work there. So I'm going to go into some options as far as tools that you can use to validate MTConnect on your own before we get into some labs. So I'm always a huge fan of Notepad++, specifically with the use of the XML tools plugin. That plugin allows me to specify schemas. I can do XPath tests. I can change the pretty print format or linearize it. It's a very powerful plugin. Highly recommend it. But I also prefer Notepad++ for its syntax highlighting. Similarly, Visual Studio has some great options and extensions for IntelliSense and styling. Neil covered a lot of that in sessions 3 and 4, but that's another really good option. I spoke with Mike Rogers just as we started this session. I have a vague memory back in like 2016, maybe 2018, of a standards committee member saying that they used Microsoft Excel. They had a specific workbook that they were able to reference something like a probe or devices XML in that workbook and they had a bunch of macros and formulas set up in that workbook to validate that document in Excel. So that's kind of a unique approach. It's a lot of work. I've done some similar work before, but I thought that was pretty cool. And then obviously I keep talking about the reference C++ agent, with its implementation of active validation, and Metalogy's meta agent is similar. And then again, TAM's online validator and agent auditor. If anybody else starts to see examples of MCNEC validation, I would love to hear about it. I'd love to be able to kind of promote those as tools that the community can use. All right, so we're going to dive into a quick lab where I'm just going to kind of show you the daunting task of what it looks like to do this all by hand. So here I have a couple examples of device configuration files. So these are used to configure the agent. Neil covered a lot of this in session 3 and 4. But to kind of go step through, the basics of this process. So as I mentioned before, I typically start off by looking at either the XML namespace to reference the version of MTConnect that's intended, or you could potentially use the version attribute. Personally, I find that referencing the schema is the most solid way of understanding the intended version, because this is rarely deviating from the major dot minor version scheme. It has a much more direct reference to the release schedule of MCConnect, whereas as you can see here, this is a 4 dot version number. There may be some confusion on whether or not this applies to the version of MCConnect or the agent or the adapter or kind of some weird combination of all three. So,
Trey,
go
just
ahead, Mike.
remind everyone, where do those two version IDs come from?
I'm sorry.
Where do those two version numbers come from when you're looking at an XML document like that on a probe?
Yeah, so it's always in the root node. You can always, or should always, find a reference to the XML namespace in the root node. That's just sort of a XML best practice. I don't know that it's actually required for MCConnect to specify these, but that's where there is a requirement to have version in the header node. So if you do a probe request, you should see this header in every response document. But at least in the probe, current and sample and assets response, you should see this version. And according to the standard, if I go there, and if I look at the devices response, we'll see this header node. We can get more details about this. But if I scroll down to the version property, it specifically says it should be the major, minor, and revision number of the MCNEC standard that defines the semantic data model. So if you want a full list of all the version numbers, you can go scroll down to the structure, down to version additions and deprecations. And this is a list of all the major and minor versions. Does that answer your question?
My question was, where is that version getting pulled from? Is it coming from the devices XML? You get two different versions in that header section or in that initial section of your document. Are they actually coming from your config file, your devices XML, or are they coming from somewhere else?
Yeah. So if you go into, let's look at the Haas simulator. And I'll look at the config for this. You can specify the schema version here.
There we go. Okay.
Yep. That should set the version number. Yeah, good question.
Yeah, so I wanted to make clear for everyone.
Yeah, thank you. Oh, let's go back to this document. All right. So yeah, first step, identify the version that you're working with, and then, in this case, this particular document is all good. Actually, it follows the standard in every way. I don't even think there's extensions in this document. So that's another step that I would do is I would do the Control F, and I would search for X colon. Uh, X is sort of the recommended namespace name for extensions to the MCNEC standard. I have seen other ones, but you should see those references up here in the XML root. So there is no extension. So yeah, there are no extensions in this document. And then I've gone through each of these data items, and I've looked at does it have ID, does it have category, does it have type, is the category either event, sample, or condition, and then the type is where it gets a little hazy. It, thankfully I've read enough of these that I'm familiar with a lot of the types defined in the standard. But if there's any that I'm like, I don't remember if this specific term is defined in the standard, then that's where I reference the model browser, and I'll just search, for asset removed, right? Oh, yep, it's in the standard. It is an event category, so I know we're good. Now I'll go into this example here. So this one in particular, I know has a bad example value. So here I'm evaluating the output or the stream of MCConnect, and I encountered a situation where our reporting in our dashboard broke in an earlier version, and it was because there was an execution state that came through that wasn't part of the standard terminology. We've accommodated for it now. um, but yeah, okay. So here was that example that I described earlier. Is this particular implementation had an adapter that was reporting execution correctly for months until it encountered this unique, state through normal operation where the adapter reported out 0 for execution instead of something else. So for this, this one's obvious, but it speaks to the level of understanding that's required, to pour through a document like this. Like, I inherently know that execution, has an enum tied to it. It shouldn't be an integer value. It should be a string. But in other situations, you might see, like I've seen running for execution, and this might leave you kind of like, well, it's a string, and it follows the general format. Like, let me just double check if that's part of the standard. So if I pull up execution, I can either go to that data item block, or I can go directly to the result. But I'll show you, if I'm looking at that execution type in the model, I can look at the result type, and yeah, it's an execution enum, but I don't see running in this list. So that's a violation of the implementation. Yeah, you can look at some of these other examples, and you might even see, I don't know, I might run this through our validator. Quite honestly, I've gotten lazy over the last couple of years, and I don't go through these by hand anymore. It's too much. I'll do a spot check with our validator because it catches 95% of the issues. But even a document like this, with 100, almost 200 lines, it's a lot to go through each and every one of these attributes and verify, uniqueness of the IDs, of the names in that level. Yeah. Oh, that's what this example was. So um, this one is something that I would catch often with Mazax, and it would throw me off. This one I don't think is actually invalid, but let me double check. So this one here, we have a tool group data item, but it's specifically extended. And this one always throws me off because there was a period of time where tool group was not introduced in the standard because Neil, while he was working at Mazak, was working on introducing it to the standard. So there's a bunch of 1.3 implementations of the standard that have tool group extended. Whereas if it was just 1.4 or 1.5, like a 1.4 or 1.5 agent, then I could remove this extension and just say that it's tool group. So yeah, let's just double check when that was introduced. So if I pull up tool group, it was introduced in 1.5. So ideally I should update my MCNEC agent to a version that supports 1.5, because you may not know what behavior and stuff needs to be added to fully support 1.5. Yeah, that's what I would do. All right, let's dive back in here. And the next lab is, I'm going to do it the easy route, and I'm going to use the TAMS online validator. So I'll go ahead and upload each of these documents that we just looked at by hand, so you can get an idea of a more streamlined process here. Okay. Let me make sure that I pull up the right files here. So if I open up this document, full file path, I'll browse. Okay, and so I'm using a login for this, so this might be different than what you might see if you go in yourself. But under the subscription, I get access to the full comprehensive report. And in this case, this is interesting because this is the XML file that I told you was completely good, right? Like it follows the standard, and I was mostly correct. It only has one error, but that error is pretty minute. It's actually pointing specifically to the agent component, or sorry, device. And I can actually click on this link, and it'll take me to that area in the XML. But the message says that it's missing the UUID. So if I look at look at the XML, sure enough, there's no UUID. I'm not overly familiar with the rules of UUID, so I can click on this link, and it takes me directly to the model browser where I can review. Sure enough, a device object requires UUID because the multiplicity is 1. So interesting. And that, I'm assuming this has been fixed in the agent, but I can track down what version that is. All right. So let's go through another document here. Let's look at this bad execution state. So, and this tool supports all MTConnect response documents. So devices, streams, assets, errors, and now exception reports. So I uploaded this device file that had the stream document that had the errant execution state. And we see here that there's a lot of condition ID missing issues. So this might be Yeah, this is a bit of a bleed over from an update to the standard. Let's see. And it's not actually reporting out that execution. So this is a bad example. But it does highlight that, the validation code is kind of ever evolving, and it's heavily dependent on the capabilities of the transpiler. Um, so I'm actually in the works on, I think, my fourth overhaul of the validation code using the transpiler. Um, so it looks like we broke the validation of the values here. So I'll need to fix that. And then let's try to look at another one here. So this is that extension document. Okay. Yeah, so here we have extended type already exists. And if I click on that, yeah, it's pointing to the tool group and tool suffix. So if I open up the browser and I search for tool suffix, I'm not familiar with that one. Did I click on the right one? Okay, so this is actually a reference to the fact that it's extended. So this is just a message level exception. Clicking on this one, extended type already exists. This is the error severity. And yeah, it's pointing to the tool group one, which we had looked up earlier. Searching for tool group, that indeed does exist. But again, I think we kind of broke a rule here in validation, so that the validator is supposed to contextualize the version that was implemented. So in this case, it wouldn't be an error because no, actually, I'm correct. I'm sorry, I'm tripping over myself here. In version 1.3, tool group was not implemented, so yeah, this is an error. But it's I think it's the wrong error. So, all right, let's get back into the presentation. So I think at this point, Mike, we're kind of headed into a bit more of an open discussion. Um, I I don't know if we want to bring Will and Neil in at this point, but I
Sure.
was going to kind of showcase, and maybe we can more collectively talk about use cases or examples of MCConnect where uh, the information model is really valuable, and provides a competitive advantage over other standards like maybe OPC UA with like a unified namespace. So it's kind of up to you and them.
Yeah, we can. I mean, both Neil and Will should have the ability to join us live as presenters. I think we've set them both up as presenters for this session. So if they want to join us, they're more than welcome.
Okay.
Well, you're here.
All right. So I'll kind of kick off a couple examples that I have, and then you guys can take it away. So the bottom two items here, I'm a big fan of what Chris does with his Mr. IIoT projects. He's got a lot of really cool examples of using LLMs and feeding the semantics and vocabulary into a large language model and having generative AI provide insights on what's happening from your MCNEC stream. So I encourage people to look at what he's doing on LinkedIn. Also, Insub Kim with Purdue, he's doing a lot of work with large language models and developing sound sensing AI. So we actually work pretty closely with him on another project. But he has examples, and you can click on this link where you can start to see some snapshots of what he's doing. Let's see if I can go there. So in this white paper, he's got some images here where you can see he's leveraging a combination of MTConnect and microphone sensors, and he's actually kind of combining the information model from MCNECT and the output of his artificial intelligence to provide kind of a semi-real-time like digital twin. Yeah, this image is really small. Try to blow it up here. But yeah, he has, like a kinematic model of the machine, and here in this little gray box, he's got some data items streaming through a web interface. And then he has kind of a simulation of the cut path. And then he is using that model to show how the AI is picking up different events using that sound sensor. So that's a really cool use of MCConnect that, frankly, I don't think that he could deliver the same result if he was just using, OPC UA, without a lot of, mapping and a lot of work developing tags and stuff like that.
Or you might want to grab some of those links and drop them into the chat for people that might want to follow them immediately, because they won't get it until we're able to send these out as like PDFs on the slide decks.
Yeah, I'll see if I can
including your validator and Will's site as well.
Yeah. Yeah, and then the only other kind of quick demo I can do here is an example of our Shop Connect application that we're working on. But particularly what I want to highlight is, the use of the transpiler to automate some development and provide some additional value for machine monitoring. In this case, I've done a couple things. Because we have the information model and the specific types of data items and component structures, I can simplify visualizations based off of the type. So in this case, I have availability being reported from this Haas simulator behind me. So if I click on that, I can change how it's visualized to be like an indicator, as an example. And in these types of data items, I've transpiled, sort of a standard of how to visualize those in terms of colors. So I've used the transpiler to understand what are the possible values for availability. Excuse me. So I can kind of pre-configure that for the user so they don't have to kind of invent their own view. Same thing with like execution. In this case, there's all these values written into the standard. Here's a subset of different colors that you can use to visualize that. And this what I think is valuable specifically with MTConnect over other standards or other digital twin or digital transformation efforts is, again, I don't if you have a valid implementation, I don't have to spend a bunch of time mapping all these data items and contextualizing it. The contextualization has already been done by whoever built the MCNEC solution. So I think this is a really powerful standard that can really enable these types of plug and play type of devices. The second thing I wanted to highlight here is, for these specific data items, I can hover over these and it gives me the definition as it's written in the standard for those data item types. So if I'm unclear what program is, I can hover over it and I get the definition directly from the MCNEC standard because I'm using the transpiler to kind of save a dictionary in this application. And that's something that other standards don't have, but it's made really easy with MCConnect. So, and yeah, with that, I'll pass it off. Again, if Neil or Will, if you guys have examples, I think now would be a good time to kind of showcase those.
Sure. I obviously I can't talk about ones happening at Blue, but in my previous life, I went to customers all the time, and the point I'll make on this, I'll make it up front, is that every customer has a pain point. And if you can figure out that pain point and say, can I solve that with MTConnect, you'd be surprised how many things you can solve. Case in point was this customer didn't even want to talk to me. Salesman brought me in there. We were talking to him. You could monitor your machines remotely from this building, and he had like 3 buildings with all these machines in it. And as I was talking to him, and he was about ready to kick me out of the building, somebody from the shop came in and said, "Yeah, we broke another tool and this and that. Somebody threw a bucket of water in the coolant, and ruined the concentration, and the tool blew." And I said, we can put sensors on that and monitor that and send you an email before it ever happens. And that was it. Next thing you know, every single machine in all 3 buildings has MTConnect on it. And not only was he monitoring, but he was, doing that coolant concentration and checking level and stuff like that. So it's, and it was a drop in the bucket to buy and get it implemented. So there's always a pain point that can be solved.
It's very true.
Mm-hmm.
So one of the things that I just wanted to reiterate to the group, and guys chime in as well with your input, as far as how you get your MTConnect implementations for your machines, what I've seen, and this is in my experience of being in this business for over 10, 20 years, is that there are builders, and we've talked about MCNEC. They did a phenomenal job from the very beginning. A lot of that work goes to Neil DeRozier's efforts, and also the current team at MCNEC has continued to work on this. Is they provide a quality adapter and agent that you can order for any of the machines that they support MTConnect on. That being said, one of the toughest problems we have with builders is getting them to stay current. We realize at the rate that we're kicking out new features on the MTConnect Institute here, it's really tough for them to stay on top of what's going on. And that's one of the goals. I'm the chairman of the education working group. One of the goals I have for 2026 is to figure out and to reach out to the builders community and say, what can we do better to help you make it easier to stay current and to provide the data items to your customers through your adapters and agents. Now, over the years that I've been supporting this protocol and other protocols, there's been several different ways that the builders can get you that information. Sometimes they have an internal team, as Neil and his group were at MCNEC, and they do their own work. They know their machines inside and out. They have direct access to their CNC controls, and they can provide you a quality adapter and agent. There's other builders I've run into where they farmed out they don't know MTConnect, but their customers were asking for it. So they went out and found a third party to write them an adapter and agent and provide that. The only negative to that is now they're beholden to that vendor to make any changes. And so when things come up or we improve things, that company, that OEM has to go spend money with their vendor to try to get things updated. And sometimes they don't want to run out and, they're at 1.3, 1.4, 1.5, and they're happy with that because they can tell their customers we have MTConnect. But that doesn't get you all the features that we've added in the standard, since those versions were released. And then the other option is somebody provides an adapter and nothing more. And I'm not going to name names, but I've got a builder that I ran into recently that they had a Windows-based controller, and in the corner of their config section was a turn on MTConnect. All they provided was an adapter, and it said right there, when you click this little box, you're going to get data out of port 7878. Well, what they were publishing is shutter data with nothing more. So, as the implementer, me coming into the customer saying, we're going to hook all these machines up for you, I had to go find an agent myself and configure that agent. And I didn't even have a devices XML from that builder. So we had to kind of query the output coming out of the shutter data and figure out what tags and data items we could use, and then build a devices XML that supported that. So those are the kind of differences that you get. The number one pressure we have with builders to stay current is the people that are buying their machines. If you're putting that in your, somebody, I don't know, was Will or Trey said it earlier today, that putting that in your request for quote for a brand new machine tool is that I need MTConnect data and I'm looking for tooling information, or I'm looking for that. If that goes into your RFQ and some salesman is really excited about wanting to sell you a machine, he's going to have to figure out how to meet that line item if you're going to hold him to that. So we as the Institute don't really have the pressure to get the builders to move forward. That's been my biggest frustration as the director of engineering for Predator is, we tell people we fully support MTConnect and we can implement it and we can use that as the medium to collect data for our applications. And then you get on the floor and you find out you've got this hodgepodge of adapters and agents you've got to try to work with. So the biggest thing I can tell you guys, whether you're working for an OEM, whether you're an integrator, or whether you're an end user, is we aren't doing this just because we all like getting together, every other week and talking about MTConnect. We want this to be a good source for data across the industry. And the only way it gets there is if the community, the greater community in manufacturing today's takes advantage of it and actually implements it and pushes their builders to actually do that. So, Will, Neil, you got any other comments on that topic?
Yeah, we've been trying to. It's interesting. Even I was looking at the example that as we were going on, there's some, posts in the chat, and like Julian Daniels uploaded some images from his machine tool configuration. I was looking at that. It's like, you know what? It's a 1.3 implementation. You can see from the header. But a lot of the data items actually we already support. Like, a lot of the timers, power on time, cutting time, current run time, adapter version. These are all, they have them all as extended data items. So there's a lot of things like even, with these existing controller version number, with these existing implementations where just upgrading the agent or just changing it over to the newer version and using some of the new data item types, it's already there. So, I don't know how to kind of get them to say, oh, if I just updated my device.xml and the agent version, then we'd be good to go. So I think it does come down exactly what Mike, you said. And so I think you said too. It's basically just putting back pressure from a customer or a group of customers that say, to be able to do this, we need you to provide these sets of data items. That's one thing that Trey also mentioned that I wanted us to kind of highlight, this idea of use cases. So we're trying to kind of we're trying to be the sort of, I guess, one of the first on this, but the idea is we take a business case and we boil it down to what do you require for this business case? So take something like, simple utilization. What data items are absolutely necessary to do a simple utilization metric? Well, you need like controller mode and maybe execution. So being able to say that to be able to have the capability of monitoring utilization, you must have at least these two things. You can then go and create another capability off of that says, okay, let's get a little bit fancier and say, spindle time, and say, you need utilization, and then you also need to know when your spindle is spinning. So rotational velocity, let's say. So we have, what we're going to be building out, as Trey was talking about in the validation group, is this set of use cases that tie to a set of data items, and it's going to be rules-based. That's why we thought of using OWL, was that we're going to first translate the MTConnect model and project it out as an ontology. And then from that, we're going to take it and put some inferred capabilities. So basically, you can use inference to say, okay, this machine has these set of components and data items. It must be this type of machine. It must be able to provide these business capabilities, such as monitoring utilization, modeling spindle time, these types of, let's say maintenance metrics, or I don't know, just basically we need help with this stuff too. We need your use cases, and the use cases can then drive down to, what we're trying to do. Do you need telemetry? Do you want to do a full digital twin? So you need telemetry on all of your axes. You need to have kinematics. You need to have so that we can say, okay, we need to have structure, we need kinematics, we need, and we need to have the telemetry of the various different axes and so forth. So providing all that as a set of rules then gets us to that next level. And we want to model all of that and inject it into the SysML model, have some simple open source technology that can extract those rules. We can take your device XML, project it out, use additional complex validation that will go beyond what we can just do in the model, but we want to do like complex validation, like, a device must have these data items, and you must, this type of component should have these types of data items, all that kind of stuff. So we can build that out as a set of shapes, shackled shapes, and rules, axioms. That's kind of where we're heading right now. It's sort of an exciting new direction for the standard because we were struggling with finding a language to express this.
Yeah, you kind of touched on something here, Will, that
Sure.
I know in my experience with MCConnect, I think I was made aware of MTConnect around 2013, played around with it for a couple of years before I started attending the tag meetings. But I remember as far back as probably 2015, there being a conversation about like, oh, we need tools for validating these implementations because everywhere we go to connect to MTConnect, we have to change something or it's difficult to edit the device's XML and really understand what you're looking at. And I think now we're at a really interesting point with MCNECT, with the SysML model, especially as a game changer for the standard. Tools like the Transpiler, I think it needs to be leveraged more by the other vendors. But I think stuff like that is really just kind of, it's evolved to a point now where we're able to deliver on a lot of the dreams and promises that we had back in 2015.
Mm-hmm.
So Trey,
Yeah.
Can you jump to your last page with the resources? So obviously this was actually the next one. Yeah, perfect. So this is our first boot camp that we've resurrected. Neil and his crew at Mazak had done this for years. And when he moved on and left Mazak was nice enough to let us take the resources and to build this setup that you've been listening to for the last 3 days. We're going to continue this. We want to hear more from our community of what more do you need from us? What can we work on? So we created an email this afternoon called at bootcamp@projects.mtconnect.org. If you've got something that we haven't addressed or you've got an immediate need before we get a chance to get all these slide decks out to you in the next week or so, by all means, shoot us an email at that email address that's on the screen, and we will try to get back to it. There's a couple of things from the education working group that I want to focus on. I think what I've heard in the comments and what we put together is, okay, I've got a shop, and again, you can have 4 or 5 machines, which is not that big of a deal to manage, but I have customers that have 150 to 200 machines in a shop. Maybe not all of them are MTConnect, but a good portion of them might be. That becomes a daunting task if you've got to deal with 150 machines with agents and adapters that are all over the place. So, Neil, if you don't mind talking for a second about, you made the comment earlier yesterday that for your environment today, you use your own agent. You don't use anybody else's agent. I think we have a topic there for another event of how do I go about consolidating my agents so that I'm working with the same agent for all the machines? Because obviously what we've said in the last 3 days is that's definitely doable.
Yeah, I mean, I use the Institute's reference agent, right? But I'm using the latest and greatest almost, not 2.6 yet, but, I have, can't be too specific, but I have hundreds of pieces of equipment and agents running, with data coming in from many channels. So I like having the extra features. I help push you guys to get the white paper for ingesting MQTT in addition to the shutter. And it pays off, right? So the work when you join the institute and you contribute and you have a need and you're willing to offer a little bit of work on it, it gets done. And I think it's great. Having seen, being on the OEM side and now being on the customer side, it feels weird because now I get to push, right? I have use cases and I get to push the institute for things we need, different topics, different areas on our roadmap as well. But yeah, no, the Institute's agent is where I want to be. We use it in different environments. So we have, Windows and Linux and stuff like that, Docker. But it gets the job done. And you guys have been Will specifically has been very, very responsive, the agent working group, and any issues that we find. If you go to the CPP agent issues, when you post an issue in there and you have any issue, it usually gets resolved within a day or two. I think Will's the type of guy where if he sees an issue, it'll keep him up all night and he'll fix it. So
Yeah.
he can't handle seeing that list grow. So
Makes me sad.
Yeah.
So
appreciate
Neil,
it.
I have a question for you. With the fact that you're doing a really good job of staying current, what kind of a task is it when 2.6 or 2.7 gets released and now you've got to upgrade? Is that a major task in trying to run around with a large number of machines and making sure that everybody's updated? Or is that something that you've found a way to automate that and make it a little less painful?
No, it's less painful. The issue is it's not painful at all, but the testing has to happen, right? We have to validate that agent and that version before we'll ever put it in production. And of course, you're going to want to run it in dev with a subset of machines, right? And staging, and before you ever go to production. That's the big part that usually, a week of working on it and making sure that it tests out well. I think what's great is every issue that I've ever found and reported to Will, not only does he fix it, he adds a unit test for it, right? And make sure that that's not going to ever happen again. The code's never going to come across that fault again. And as time goes on, I get an agent and for the most part, it just works, right? Other than unless it's a new feature where we want to test out. It's been fantastic.
Thanks, Neil.
Okay,
Appreciate
great. Use that email. I've seen a lot of things in the chats for the last couple of days. It's a little bit of a daunting task to go through all 6 chats and figure out what you guys are asking for. So by all means, drop, if you requested something in the chat or it's something you'd like to see for a future training session, please drop it into, an email at bootcamp@projects.mtconnect.org, and we will stay on top of that. Again, if you'd like to participate and this seems interesting to you and you want to be part of the decision-making team, by all means, join the Institute. We will include information in the emails we send out to you guys after this is all over with about how to join and how to get on. Some of you, if you're already working for a company that's already signed the intellectual property agreement, that may be a no-brainer. Your company's already part of the team. So that won't be a big deal to have you added in and decide which working group. If you go back to day 1 and you look at the slide of all the different working groups we have, if there's a particular niche of the MTConnect that you're interested in or that you've got some needs for, we'd love to have you on the individual working groups. We meet about once or usually they all meet about twice a month, usually on Mondays actually some are Mondays, some are Wednesdays, different days and different times. We try to deal with people's time zones and being in different parts of the world. Actually, we have people joining like Will from Europe, and we have a couple of gentlemen that are part of the group that are from India. So we do have people from all over the world that are part of the group at the moment.
Mike, I'm wondering, I see the question there was the best place to look for help. I'm wondering if we should do a monthly office hours type meeting where it's just a Teams meeting like this for an hour or something.
I think that would be a great idea.
But we definitely have to market it, right? We have to publish it and get it out there and make sure it's social media that people are aware that it's available, and then they can join up for it. Yeah.
Yep, I think that's great. All right. If you got any more comments, we're looking at the chats to see what you guys are. Anybody got anything else, or we can wrap this up? I want to thank our entire team, Will, Trey, Neil. We've all put in a lot of work to get this online and to get this up and running. And I think it's been a pretty well received sessions for these 3 days. I certainly am very pleased with the attendance we've gotten. Please tell your your coworkers about it. We will be having, more of these to try to get the word out. Obviously, we haven't hit the entire world with the number of people we've had today, but it's been very, very good from our end. So we appreciate you guys taking the time on 3 days to attend. Anything else from my team?
No, just Mike, I want to really thank you. You put a huge amount of effort into this, and pushing a large rock up a big hill.
like herding cats, right?
Yeah.
Well, it's a rock. It's a rock that needed to get moved. I was just hoping not to get rolled over by it. So yeah, no, this worked out really good. So I'm pretty happy with everything. And I want to thank the team for putting this together, and our support team on the back end that no one sees from AMT, Alyssa and her group. We appreciate the support. So,
and Ryan also for fearless leader over at AMT, who is the VP of Technology. He also was instrumental in also herding the AMT cats. So it's a lot of work to put one of these things together, and I appreciate everybody. Yeah, and this is not the last. So
nope.
So we plan to do more. Please also give us feedback as to anything else you'd like us to cover in more depth. Of course, we kind of did a survey of information based on Neil's. Also, let's thank Mazak for donating a lot of the materials that Neil put together, and Neil for putting those together in the first place. Yeah. So the next boot camps, we want to find out, like, what do you want to hear more about? You've had you had sort of an overview. You've seen a lot of different things. We've sort of touched on a lot of different topics. We could go deep on many different areas. So we need to get you to tell us where to go.
So one of the comments I want to add on that is this was sort of a webinar format where we're presenting and you're listening and we're watching your chats. We're more than willing to do, a smaller, maybe 1 hour or 1 or 2 hour on a day, where it's a little more open and you guys can actually ask questions and participate the same way we would if we were in a room together. So we can change up that format. That may be a little more enlightening on certain topics, but it was not something we wanted to open up to. We had no idea that we were going to have 100 people or 500 people or 2 people in this boot camp this week. So that's why we kept it to the webinar format that we've been using. But we certainly are open to doing smaller 1 day, 2 hour sessions where you guys can actively participate, ask questions, and maybe we can have the presenters doing real life demos on connecting to a machine or something along those lines. So we're open to that. Give us your feedback. We will get a questionnaire out to you guys as well, and we will be providing the slide decks as PDFs. The videos, you should be getting emails immediately after the session closes, or I would not say immediately, within the next morning, of a link to the download, so you could download the raw video from these 6 sessions. But we are going to take these 6 videos that we've recorded and clean them up, put a little chapters to them, and then probably dump them on one of our YouTube sites, so they'll be available to a broader audience. But you as attendees have access to these immediately if you wanted to go back and review certain sections that Trey or Will or Neil were talking about. So with that, I think we're good. I want to thank everyone for attending, and have a great weekend, and we'll hope to see you soon again.
Thanks again, Mike.
Thank you.